How are Rossby waves formed? Have you ever wondered how the weather patterns we experience are influenced by waves high up in the atmosphere? One fascinating aspect of this is the formation of Rossby waves, especially in the polar regions. Let's break down how these waves come to be and what role they play in our climate and weather. Rossby waves, also known as planetary waves, are large-scale meanders in the atmosphere and oceans. They are essential for shaping weather and climate, particularly in the polar regions. The formation of these waves is rooted in the physics of rotating fluids, like the air and water on Earth. At a fundamental level, Rossby waves are created due to differences in temperature and the rotation of our planet. The equator receives more solar energy than the poles, leading to a temperature gradient. To balance this out, air moves from the poles toward the equator and vice versa. However, this movement does not happen in a straight line. Instead, it twists into large, slow-moving waves because of the Earth's rotation. This twisting effect is known as the Coriolis force, which varies with latitude and is a key factor in the formation of Rossby waves. The main driver of Rossby waves is what scientists call planetary vorticity. This is a measure of the spin created by the Earth's rotation. The gradient of this vorticity is strongest in the mid-latitudes and weakens as you move toward the poles. In the polar regions, the conditions for classic Rossby wave formation are not as ideal. The change in the Coriolis force with latitude, often referred to as the beta effect, is smaller here. However, Rossby waves can still influence polar weather, especially when there are strong gradients in wind or temperature. In the context of the polar regions, Rossby waves often interact with other features like the polar vortex. The polar vortex is a large area of low pressure and cold air surrounding the poles. While isolated swirling weather systems tend to dominate polar circulation, some wave-like patterns can still be detected. These waves may be triggered by disturbances far away, such as tropical heating events that send waves toward the poles. Once these waves reach the polar regions, they can affect the stability and movement of the polar vortex, leading to changes in weather patterns that can last 4 weeks. Understanding Rossby waves is important because they help explain why polar weather can be linked to events thousands of kilometers away. For instance, a sudden warming event in the stratosphere over the Arctic, often connected to Rossby wave activity, can disrupt the polar vortex. This disruption can lead to unusually cold outbreaks in mid-latitude regions. Additionally, changes in sea ice cover can alter local heating patterns, potentially triggering weak Rossby wave responses that influence polar climate variability. In summary, Rossby waves are formed by the combination of Earth's rotation and temperature differences between the equator and the poles. While their classic formation is strongest in the mid-latitudes, they still have a detectable impact on polar weather and climate. Their ability to connect distant parts of the planet makes them a key piece in understanding both everyday weather and longer-term climate trends in the polar regions.